Welcome to the Domain Relational Calculus Part 2. Here we will do some examples based on Domain Relational Calculus. So our first query is find the loan number, branch name and amount for loans over 1200. So this query uses the relation loan with three attributes, and the domain variables for these three attributes are L, B and A. So because we have to output all the three attributes, so we use three domain variables for output. So this output part is always written before this pipe character. Now in the predicate part we can write several atoms, and the first atom is from the loan relation, which consists of the three attributes L, B and A. So this is the relation we will be using for outputting this. The second atom consists of the condition, and the condition is that the amount should be greater than 1200, and the domain variable for amount is A. So here we can write this. Now the second query is find all loan numbers for loans with amount greater than this particular amount. So these two queries are very similar, but here we have to output only the loan number, which is represented by the domain variable L. Next, the relation is the same, the predicate is the same, but here because only one output variable is there, all the other remaining variables we have to put with the existential qualifier regarding branch name and amount. So the remaining are branch name and amount because we have already used L. So what are the two remaining? The two remaining variables are B and A. So after using B and A, nothing is remain. So we say that all the variables in the branch relation have been used. This very similar query is for the instructor relation. Here we have to output all the variables. So all the variables are represented by I and D and S. So here I and D, S are the output variable, the instructor is the relation, and the condition is on the salary, which is represented by the domain variable S. Here in this next query where we have to find only the instructor ID, instructor ID is represented by the domain variable I. So only I has to be input. Then the relation consists of the four domain variables I and DS. Condition, other condition is that the salary should be greater than 80,000. Now out of I and DS we have already output the variable I. So what the remaining domain variables are N, B and S. So we can put all those with the help of existential qualifier. Now consider one other type of query which uses two relations. Find the names of customers who have loan from the branch and find the loan amount. So we have to find the customers who are having the loan at the branch and also print loan amount. So this loan amount is printed from the loan, but the name of the customer cannot be printed, so we use another relation, borrower. So this borrower relation consists of two attributes, customer name and loan number, for which we have used two different domain variables C and L. Now remember, this loan number was from the loan relation, and since this is a join, so in the join we use the same variable for loan number in the loan relation as well as loan number in the borrower relation, because here we are outputting the result based on the join of the two. Okay, so here names and amount is required to be printed because we have to find the loan amount. So the customer name is represented by D, so we have used this D, and the loan amount is represented by A, so we have used this A. So out of these domain variables we have already used C and A. Okay, so the borrower relation consists of the two domain variables C and L. From the C and L, C has already been used as an output variable, so the remaining is L. So now we are using this with the existential qualifier and use this L also. Now this is only one part of the query, and the other atom consists of the loan relation, which consists of the three domain variables L, B and A. Out of these three we have already printed L. So this L is also marked A was already taken as an output, so what is remaining? This B. So we have also printed this B. Okay. Now the condition for this condition is on the branch. So branch is represented by B and B is equal to parent. So because this condition is only on the loan relation itself, so for this part of the atom we don't require to represent the name of the relation, because the name of the relation is loan, because this part of the parenthesis is contained, this parentage branch is with the from the loan relation itself, because this parenthesis ends at this particular location. Now there is another similar query which uses two relation, that means it is once again a join, and whenever a join is there we use the AND operator as we have used in this query. So here the query is find the names of all instructors in the physics department together with the course ID. So the instructor consists of ID, name, department and salary, but what we require is course ID, which is not there in the instructor, so which this is in the teacher's relation, and the column attribute that joins these two relations is the ID. So here we can use these two relations. So the domain variable for the ID, because it is a join, so the domain variable for ID in both the relation will be same, and here we have used the domain variable I in teachers for representing ID and I for teaching ID, representing ID in the instructor relation. Okay. So we have to output names together with the course ID. So name is from instructor relation, and this is with the variable N, and course ID is from teachers, and this is represented by the domain variable C. So the output variables, domain variables are N and C. So the first part of the query consists of the teachers relation, where we use I, C, A, S, Y as the domain variables which belong to teachers relation, and out of this I, C, A, S, Y we have already used C. So we mark this C. So what else is remaining is I, A, S, Y. So I, A, S, Y is now used. So this I is now used, and this I is also in the instructor relation. So we also mark this. Okay. Now comes that these we have to print the name of the instructor also. So this name of the instructor is from the instructor relation, so we use instructor relation, and this instructor relation consists of I and DL as a domain variables. Out of I and DL, N was already printed as an output, so we mark this N also, and I was used in this teachers relation, so I is already marked, so the remaining are D and L, so we write D and L. And the condition for physics is for the department, and for the department we use the domain variable D, and this department should be equal to physics. So we have used all the domain variables A, S and Y this query is now O. Now take one another query which uses union. So for union we need to use the union operator. So this is our union operator. Okay. So the query is find the names of all customers who have a loan or an account or both. So loan and account. So loan information comes from the loan relation, but we require the names of the customers. So the name of the customers will be from the borrower relation. We need information for the account, and the account information comes from the account relation, and the name of the customer who is having an account comes from the relation depositor. Now different from the previous in which we were using the join, here we have the union operator. So union operator when we are using, then the first part of the query, that means find the names of the customers who have a loan, will be taken from these two relations, loan and borrower, and the second part of the query, that find the customers who have an account, will be taken from depositor and account. these first two relations, they will be using the join. So here we will keep in mind that whatever is marked as being used in any relation will also be marked as used in the other relation, that particular domain variable. Similarly, these two, depositor and account, there will be a join between these two relations, but these two relations are different from loan and borrower, and these we will separately come up with the two relations, one from loan and borrower for the loan and one from depositor and account for the account, and then we will be performing some union of the two. So let us see the first part of the query. Find the names of all customers who have a loan. So loan, from the borrower we have customer name and loan number, and customer name and loan number, as we had done previously, customer name and loan number, we have used the variables C and L. So C and L we have used, and for loan we have used L, B and A, as we have done in the previous example. So C and L is for the borrower, and from the borrower we require the names of the customers. Name of the customer is represented by C. So we have already output C. So the remaining variable is only L. So we have written L. So both the two are finished from this borrower. Now we have the condition for loan and the pairage, and this branch pairage and the loan relation consists the information regarding branch name and loan number. So the loan relation has three attributes: loan number, branch name and amount. So we have used all the three domain variables. Out of these three domain variables, we have already printed L along with the borrower. So this L also needs to be marked. Now the two remaining are only P and A, so we mark P and A. So now all the variables here are also finished. So this forms the first part of the union operation. The second part is for the customers who are having an account. For finding this information, we use depositor and account relation, where we can find the name of the depositor and his account number, and the branch where he is having the account. So the depositor relation here consists of the two variables C and A, but because we require the information of the name of the customer, so because name of the customer is the common attribute and the branch is also the common attribute, so for branch and the name of the customer we will be using the same variables. So for branch, in the loan we have used the variable B, and for the account, for the branch, we will be using the same variable P. So definitely the variables will be same, and here also like the name of the customer is C, and here also in the name borrower relation, the name of the customer will be C. So the name of the variables will be the same, but what is to be output, what has to be the output from the union is, we will not cancel C and B here because this is another part of the query. Okay. So from the depositor we have C and A. C is the name of the customer and the name of the customer is the main output, and so because we have used C as the main output, so we will mark the C here. Now what is remaining from the depositor is only A, so we mark this A also with the existential qualifier and mark this variable as used in the depositor relation. Now we have to find out that this depositor has an account at the pairage branch. So the account relation has the three attributes A, B and N, where B is representing the branch name, and as we have already learned, branch name is represented by B. So A, B and N is, we are representing A, B and N. So out of this A, B and N, because we have already used A, which is representing the, sorry, this is depositor, account number is A. So but this A is different from the one which we have already used. So account here is A, B and N, but we have used this account number in the depositor. So So this depositor A is already used. So the remaining from the account are B and N. So we are outputting B and N. So this finishes all the attributes of the account relation, and the other is the condition that it is beverage branch, and in this account relation branch is represented by the domain variable B. So B is equal to beverage. So here, as we have already seen that here, because with the loan relation we have output A, so we just forgot to mark this variable. So all the domain variables are now used and the query is finished. Now the next is again from the union operator, and this query is says that the find the set of all courses taught in fall 2009 semester, the spring 2010 semester, or both. So first of all we have to find the courses in fall 2009, then spring 2010, and some courses might be which are there in 2009 and spring, so we have to use those courses also. So now see here the entire information regarding the set of courses, course ID and semester. So this is from only one relation section. So only one relation is required to fulfill this query. But since this is a not a join operation, this is a union operation, and union operation means this is the first part of the query. This is very much different from the second part of the query. So once we will be writing the query with this green, and second time for the union operation we will be writing the query for this black section. So now for the first part of the query we have CASYBRT from the section relation, and we want to output the name of the course, or we can find out because the name word is not specified, so we have only the course ID. So this course ID is output as C. Now because here we are interested only in the course and whether that course is running in which building or at which time slot or in which year, we are not we are interested in the year 2009 and 2010. So year is required. So we can here also write only because we are writing query for the semester and year, and this semester and year can be used as output along with S, and we can also use all other variable like C, A, no not C because C is already output, A, S, Y, B, R, T, or we can also write S and Y, or we can here we have simply write S because only even this will work. So there is nothing to confuse. We can as we have learned previously that whatever remaining variables are there, so the remaining variables are A, S, Y, B, R, T. So we can write all the variables with the existential qualifier. Instead of S we can also write A, S, Y, B, R, T, and then the condition is that the semester should be fall and the year should be 2009. So other two atoms are that the semester should be fall and year is equal to 2009. So this forms first part of the union operation for the fall 2009 semester. The second part is for the spring. Once again we will choose the same relation. This relation has all these different domain variables, and out of these different variables, because we have already used the C as an output, so the remaining are A, S, Y, B, R, T. So we can also write A, S, Y, B, R, T instead of S. Then the condition is that the semester should be spring. So semester is represented by spring and the year is represented by 2010, and this is the variable Y. So Y is equal to 2010. So this forms the result of the domain relational calculus query for the following question query. Now let us come to another query which is using the for all and uses the implies operator. Such queries are there when like the query is find the names of all customers who have an account at all the branches. So whenever there is some term like at all the branches, then we use the implied character, and also this instead of existential qualifier we use the for all qualifier. Now how do we write this query is we want to find the names of customers. So the names of the customer will come from the customer table. Okay. Then we have who have an account. So if the customer has an account, then the account information will come from this account relation, that he has an account and account number is same. So this attribute will be sufficient for joining these two tables. Now the condition is that the branch should be Brooklyn. So branch name is there here, and then the branch name is Brooklyn. So this will comes from this is okay, but here we have used Y. Y means this. Okay. So we have used see just a minute. So why for this we have used in the branch relation we have used branch name, branch city and asset, and here we are representing branch city with Y. So here we have used Y. Okay. Now see how are we writing this query is find the names of all the customers. So the name of the customer is C. So this relation uses the relation customer. This customer relation consists of two attributes C and N, but here we have some discrepancies are there. So what we will do is we will learn about this query